Hello everyone. Today again I wanna talk about soldering and different PCBs and different types of components. For example, that PCB is just a single-sided, really simple PCB with all through-hole components. IC, transistors, everything is through-hole. If you need to remove components, it's really easy. Depend on the component. It's like, for example, transistor. The easy way is just take some solder, find the pins. Let me zoom it a little bit. For example, this transistor here, it's three pin components, but just 3 pins. Okay, now is better, I hope. Okay. Yeah, for example, this one on the edge. Directly, we got the three legs, 3 pins. That's really easy. Take the little bit of solder, add and connect all the 3 pins. Then you can hold it and pull it, but be careful because that's getting hot. And the best way for this will be use the tweezers. And put the tweezers like you can put the force to pull the component down, and then just little bit of, and as you can see, nice and easy. Then if you need a clean, just take excess of the solder, and then to clean the holes, I'm using solder wick. It's some people call this desolder wire, but it's really good, and yeah, that's it. Nice and clean. Just to make sure we clean the one. And as you can see, nice, clean. For the IC, you need to remove solder first. I prefer the method when it's also just use the solder wick to take the solder out. It's not big thermal mass, and the PCB is just a single side PCB. It's easy. It's really easy. Just take your time and remove the solder from every leg. And now, as you can see, the pins are relatively not soldered. Find a good point, but as you can see, still a little bit stuck. Then make sure that some of the pins are still attached slightly, because the little bit of solder is under It's not too much, but enough to keep your component down, and just lift and bend the... See, some are really stuck. Paper based, and is really sensitive to overheat. Now your component is removed, you save component. That's great. But as you can see, I lift the edge of the parts. Let's look under microscope. Still, you can solder, it's okay, but it's small damage. That's the reason why first you should make this gently. As you can see that side, you make this really gently and it's fine, no problem. If you care only about the component, and you much more to care about the component, for example, which is not really available, you need to take from some old retro electronics, and you don't care about the PCB, that's perfectly fine. You need to more care about the component, and the PCB you can damage, but remember, I just make that side really hard and damage this on purpose, just to show you how easy is the old PCBs are getting. Even if you apply a little bit too much heat. For example, we got this one. Now apply a little bit heat. Keep this, you know, a little bit longer. I know you can't smell it, but it's that is getting really weak on the around. Surprisingly, this is not bad quality. It's not the worst quality, right? So, but yeah, let's apply a little bit of solder. Make this bigger. Microscope is. This one. Yeah, let's look on this one. Buy some solder. You see, it's burned straight. And it's like almost no force, just bang, and it's going off PCB. Now you got a broken track. As you can see, it's not highly integrated. It's just got some even 2 ICs, capacitors, 5, 6 transistors. That's definitely not a cheap way to build stuff, but it's relatively old. The same style PCB, single side, that's from the CD-ROM drive. Is that funny old device when you put the CD disc, compact disc, to your computer. Some and switch here, LED, and some button. I think it was the eject. Yeah, it's eject. It's connected. Just that's the same style of the single and through hole components, but that's the old technology, And if you want more about the old technology and how to deal with that, I can make the next video. But let's look on this. That is really interesting because we got two variants of the same. That was the controller for the emergency lights, LED driver. As you can see, yes, the scrap, because it's from the production line, and for some reason some components was not right or not placed properly, and when people make the rework, probably they make some damage. And here those components is the diodes. I can show you under microscope again. Let's back microscope, and as you can see, that's really badly damaged. Yeah, the part is gone completely. Is on the components on the double on the other side, and this side it will be really difficult to remove the components or to replace the components. The reason why is because the when it's going to the oven for the final solder, going like that to the oven, the under components need to stay there. And the solder paste, when it's print the solder paste, the tension is not enough to hold the components. When it's going to the oven, could easily fall off. And in the production line, we use the trick. The trick is, as you can see on almost every component here, yeah, you got this. You got that yellow stuff, which is glue. And a small drop of glue. I will show you part where the component was here. It's no component. Probably that stay from the previous revision. And we got the track here. Maybe it was the fuse or something. But you got the glue here, and the all components when the machine is placing is just put on that and is stay, because the glue, the board is going for the, like, for example, I don't know, hour or two to curing process, and after that is going to the oven, and then the other side is populate and going to the oven. And trust me, that is really difficult. That you need a hot air and lot of patience. Let's try. Let's try and let's see if we can remove without the damage. I want to remove that I see. 390 degrees, the air flow just really minimum, like 2. And let's warm it up, see how it looks like. Always to help with this process, you can add the gel. In the meantime, I will switch to the desk camera and I will show you the type of this one is the specific to desolder and truck flux. That is really jelly and it's good stuff. And also more popular, I think, is the no clean flux. It's again like gel, and it's really help to solder because it's lower the melting point of the solder, and also especially the chip quick is designed to hold the little bit of heat. But remember, you need a good ventilation, or the best, it will be fume extraction with that process. Let's look. That PCB got the really massive tracks, and even internal tracks are really big. And you see, we melt already solder, but I can't move the component, which is really difficult. Solder is melted, but I can't remove the component. To break this glue, yeah, sorry, I just moved and I just jump. You see this massive 2 drops of glue? Component was here and was really glued, and that's the reason why it's really difficult to desolder. Don't set too high temperature, don't go to the max, because you will damage definitely the component, or you need to do slowly. If the board was in some place where you expect it was the moisture, don't go straight to really high temperature. Take time, set to like 100 degrees, give this like 30 seconds or even 1 minute to spread the heat around and to warm the whole PCB. That reduce the chance of the what we call the popcorn effect, because the moisture is trapped inside the PCB, many layers, and the more complicated board got the much more layers, and that's the entrance point for the moisture, and easily just will pop, and probably your PCB is damaged, because any internal connection between the layers will be broken. The next important bit from this side here, because of design, when we design the PCB, we always need to think about what components we can put on this side. And as you can see, is the not big or no true hole components on this side, and nothing like capacitors here. Components which are more sensitive for the heat, especially electrolytic capacitors. They are really sensitive to heat. You can easily damage. And those capacitors, that foil caps, and if I blow here, if you for example need to remove that component, that it's tricky. You first need to remove the components, sensitive components around. If it's not possible, you can use Kapton tape. Kapton tape is the gold shiny tape, but it's really resistive to the heat. That tape is designed to cover components around. You can, for example, if really for some reason you can't do it, just you can put around make sure is cover to the bottom, because when you blow, the hot air will go there. But be honest, the chance to survive this capacitors here is absolutely, maybe not zero, but minimum. Cover even the components which are a few centimeters from this point. Cover them, the electrolytic capacitors, and all plastics or even that pin header, that will also melt. Let's remove those capacitors. I want to remove them to give them more space, and I will use exactly the same technique as before, but with that PCB, because it's the big chance one side of the capacitor which will be connected to the ground. Grounding points are really not helping you with the soldering or desoldering, because like the heatsink, they take all the heat and spread. They're doing the job, be honest, because this PCB is designed, as you can see, those this massive area, and you got a lot of the wires there. It's not only for the electrical connection, it's more to thermal coupling, and it's working as the heatsink. But the best way, if you need to remove the component, just warm it up gently, slowly warm it up, all this area. And we got the two capacitors here, those blue, and two here. You can see, yeah, those two, those two. Just take time and make this properly, because that will help, really help. I think that's enough. Then add some fresh solder. Because fresh solder normally got a lower melting point. And then what I'm doing, I just pull with my finger one side, so you can see one side is gone. No? We free the capacitor, and then the next side and the next capacitor. And that is really easy. Do this gently. Always care about your tip, because that's what is your connection to the PCB, thermal connection. Again, fresh solder. I hold for the moment to give the time to heat go, and I use the finger to push down, and when the solder melt, they just go. See? And I'm doing this from the other side now. Exactly the same way. Up. And then repeat with the bottom again. Bottom legs. Okay. That's it. Capacitor safe and okay. No problem. And now, if you got the preheater, the preheater is really good, but I understand it's not everyone got a preheater. If you, for example, want to remove that component, trust me, that is not easy. As you can see again, that whole surface is he is sitting flat on the PCB and is directly on that massive area, which will get the heat out of the component. Because when it's working, the all generated heat is need to go somewhere, and that's the, you can say, the design heatsink here, to not add the extra, because the many times if you need to add to extra heatsink is the more complex, more chemicals involved if you need to glue it, and is the next step on the process, and this means really increase the costs. And if you design PCB and you can do it, you got enough space, just that's the way how you do it. And to see the next power component, next, and we 1, 2, 3, 4. If you look here, we got 1, 2, 3, 4. 4 components, switching components. Oh, this one is the diodes, but we got the 2 transistors here. And what I'm doing now, it just, I can say I'm really simulating the preheater. And just I preheat the PCB from the bottom. That is really, and give the time, don't put too much heat, don't stress the PCB, because it looks stiff, but it's not. It's easy to destroy. I'm just moving just to spread this from, because of course the nozzle is just for small component. I want to warm it up, all this area. If you warm it up the area, also the stress for the PCB is the less stress, because warming up on the whole surface, not on the point. It's not single point of stress. Okay, that's it. And then set your airflow to minimum and use the gel. Always use the gel, and as you can see, I need to now with the gel. Unfortunately, it's really smoky, but with gel it's just a pleasure to work. It's smoky, but it really helps. You can see when it's getting shiny, really shiny solder. See, those points are melted, but still that component is there. I can't move because of that area. I show you something what I how easy is damage other components when you're blowing the heat. And you see, it's still there. I can't even move. You can help, just take your soldering iron and add little bit extra heat there. See? It's moving, it's melting. And up. Done. The same with this one. I'll add a little bit of solder. See, the solder is really melting well, nicely. But this component is much bigger. You see, it's still stuck. You can see that I'm lifting the legs, but the body is still attached there. I will take again the soldering iron and I will help a little bit. Now, hop, it's gone, and it's here. And it's here. Nice. But look what I done. I pull too hard and that was not melted and I broke the pot. and I really broke the part. That's not good. That is really bad. No, it's mean PCB is damaged. But also, what I was doing on purpose, I said always cover plastic components. Let's look on the microscope. Now, maybe first I will show you the big component. Look on this relay. Now your relay is damaged. The risk of fail is like no questions. No questions. But the next bit, I show you under microscope again. This is melted. It was close, really close to that pad. It's really close from this pad, and I was blowing really closely. And now it's melted. It will still works, but it's not looks okay. It looks like made some butcher is doing. Again, not good. It will be completely different story if you wanna remove this big chokes, because they are massive. Good point, they could survive a lot of heat, but they are on the massive parts. You need to give the lot of heat. And then I will show you how massive different is when I will use preheater. And now we have preheater here. And let's use the same PCB. Always set your PCB as close as possible to the center of the preheater. Make sure it's ready, it's tight. You don't need to use all of them. All this, that is enough. Just keep the PCB. Yeah. Now we can plug the preheater. Not on yet. Then set to 100 degrees and wait. Give this time. Really, give this time. And I will use now the thermal camera to show you how. Currently our PCB got 60 degrees. Even below, because I can still touch. It's not that hot. The thermal camera show me 50 something, 60 degrees. When you give this like 30 seconds or more, 1 minute even, I will increase to, like, for example, 160. Increase with some steps. Don't hurry. And now the heaters shows like reach 200 degrees, but of course the heaters will be always hotter. But our PCB from the top is still 60, getting really slowly up. 64 degrees. It's really slowly. Definitely, that's it's big thermal mass. 66. Slowly get to the point. Now I increase to 200. camera shows like 180, but the PCB is just getting 70. 22. And like I said, there's no reason to rush. Only if you, I don't know, try to repair the Peacemaker to save someone's lives. Of course, it's the joke. Peacemaker is really slow and encapsulated, but yeah, it's something you don't need to be hurry. Just take time. And that's the key to the success. If you do it properly, it's less stress for the components, less stress for the PCB. Because when you set straight to, I don't know, preheater to 200 or 250, you just straight give them massive heat from the bottom, and the difference between bottom and top is massive. And again, if there's any moisture trap, it's no time to escape. Even with that method, some really the PCBs which was in really bad conditions, really high humidity, and could broke. Yeah. And even now, after that time, it's like 80. 85, 86 degrees, 7. I'll give the time to reach like 90 degrees. 90, okay. Getting. See, the heat is accumulated now and getting now better. Okay, we reach 98. I know some points, even 100. You see, now I'm sure the heat stress only. And now I'll take my heat. Hot air gun ends. Let's do the trick on the transistor on the edge. And let's look how quicker is melting now, because the heat not need to be transferred to the other places, to the other side, and through the PCB. It's just nice and easy. We almost melt. Yeah, this is ground point. Look, it was just easy peasy. And the next component I want to take. Oh, everything is just now preheat completely, and it's just little bit of heat, just little bit of heat. And look, next I see no problems. No problems. And what is really interesting, that side which I melted before, do you remember how badly I damaged before? Damage, I mean, I melt the edges. Of course, under microscope it looks really bad, but that's the side which was melted before when I used just the heat gun from the top without the preheater. But look here how close connector is to that place when the IC was. And look, it's just almost nothing. Seriously, if you look without the microscope, You almost can see it melt. It looks shiny, but it's nothing compared to what I done before. Preheater keep your PCB warm, and when you clean the parts, the solders melt quickly. It's no risk to leave the parts like I did before. And for the cleaning, let's switch back to the normal camera. If you need to clean the parts, I keep the board on the preheater, and it's just like that. When you need to clean the parts, you can clean the parts just like that. Easy, nice, almost no effort. Even that big part, see, still melting easily, and we get the old solder from here. That big part, okay, let's do. Look how easily it's melting now. No problem. If you're doing without the preheater, you need probably use the different solder tip, the wider. And beauty with the JBC stations, the heaters here, and it's a different heater to this one. It's different power. It's getting much more power, but it's generating much more heat on the surface. The last really important bit is the cleaning of the PCB. Never ever leave the PCB with this something like that. That's no, please, no. You can use just the isopropanol, or I will show you the different. I like the other stuff, but the isopropanol is good enough. It's something like Flux Off. The isopropanol I keep in the bottle with spray, then spray. It will be nice if you have the that's the special ESD anti-electrostatic brush to clean, and then just spray and clean. I just push on the angle and let's all the stuff go down. See? Nice and clean. This one is a little bit stronger, little bit better, because it's more aggressive chemicals there. But I found the isopropanol, it works really good. Regarding to the Flux Gel, this one is really good. This one is for more, I can say, traditional. Well, I know it's here is no clean water wash, no clean. Even this one is no clean, or some other stuff, especially something like that. That's the liquid. That's the liquid you got with the small brush on the end. And that's the liquid. I love this stuff, but what is really, remember, yeah, don't put the fire close and ventilate. Always. That's the chemical. That's the chemicals which you don't want to go to your lungs. Seriously, guys, care about yourself, and never do in the unventilated. Invest even some simple fun with the activated carbon filter. This also help I got the like the proper extractor, which the pipe is connected and going on my loft, and on the loft I got the filter box with the fan, which just suck the air. Let's look again under microscope on the path. Sorry, adjust now again. Good focus now, and look on those parts. It looks really nice and clean, as you can see, that's the difference. You don't need really expensive stuff. Remember, you can buy the second-hand preheater. My preheater, I don't really remember. I need to check how much I pay, but I found some on eBay, and theoretically it was second-hand, because the person which put this on eBay, they said, yeah, he used just for maybe 2 times and just sold us the used, and I think I paid like £80, just £80, and it's really good and enough. Always if you need some working with the bigger boats, but relatively is give you the nice working area. But as you can see, yeah, it's nice. It's no risk of damage tracks, and much better just to doing without any without preheating, because high dense components, they are really close together, and you blowing just from this side with really hot air, and the difference between 2 points could be like 200 degrees. For the PCB and the solder, is massive stress. It's massive stress. Then you can get some dry joints, because it starts melting probably on one side and it give you the dry joints. And like I said, always the stress. We analyzed loss of the PCBs under Röntgen through the X-ray machine, and we find a lot of stuff, the experience and a lot of science behind the soldering, especially with the sensitive stuff like the mobile phones. Those crap PCBs, and I can experiment on them, and I don't care if I'm doing that. If you look on the micro relays like that, they are really sensitive. They are really that the simple driver relays, but this is melts like crazy. Really sensitive. That's it for today. I hope you enjoy. See you next time.